All right, grade 11s, a new day of trig where we have something old and familiar, and I'm not going to throw anything new or scary at you. So we're going to look at the cosine law today, or the cos law. Remember, the Pythagorean theorem looks oddly like the cos law, and that was our starting point, and we're very familiar with it. The Pythagorean theorem is a specific case where the angle C is 90 degrees. And so this part of the cos law would be 0. So the cos law, c squared equals a squared plus b squared minus 2ab cos c. We're not going to write it with all different letters like you find in your textbook. We just need to recall that for the cos law, this side, little c, must be across from the angle at the other end of the equation, big angle c. We know that trigonometry is all about triangles and opposites. So for any triangle ABC, where big angle C is across from little side c, we can use the cos law. Let's find, first of all, a side, and then we'll find an angle, and then we'll do a short word problem. Let's do triangle JMB. We're going to find little side J. So if we have angle M, little m is across from it, angle B, little side B, and little side J. This is the side that I want to find. So I'm going to set up my cos law where I have little side j is across from the only angle that I know, 25 degrees. So I would need to set up the cos law as j squared equals, and big angle j would be at the end. The order of the other two doesn't matter. So I would need a 10 squared and a 12 squared minus 2 times 1 of each, cos angle J, and I happen to know angle J is 25 degrees. I would really love it if you would type that entire thing into your calculator all in one step. And sometimes we need to remind our calculator with a set of brackets that those last 4 things are glued together. 2 times 10 times 12 times cos 25. And we're adding that to 10 squared and 12 squared. If you were to do it in 2 steps, however, you'd have 100 plus 144 minus 2 times 10 times 12 times cos 25 is about 217.5. J squared is 100 plus 144, take away 217.5 approximately 26.5. To find the length of j, I'm going to take the square root, and I only need to consider the positive square root because it's a length. Side j is approximately equal to 5.1. Does that answer seem reasonable? We know that the smallest side would be across from the smallest angle, and 5.1 is certainly smaller than the other 2 sides, and a 25-degree angle out of a possible 180 is a small angle, so it is a very reasonable answer. Let's find an angle. We'll look at triangle CDB, and we want to find angle C. So this is the angle that I want. I can't use right angle triangle trig or sine law for this triangle because I don't have any angles and it's not right angled. So I am stuck with the cos law. If I want angle C, I need to start my cos law with little side c so that I can find that angle C. I'm going to write in little side B, little side D, minus 2 times 1 of each of those, cos C. So this is how I'll have to set up my cos law in order to find angle C. Putting in numbers, 24 squared equals 20 squared plus 10 squared minus 2 times the 20 and the 10 cos C. Now my goal is to get cos C by itself. So before I even touch a calculator, I would like to get rid of all of the extras on the right side so that I can isolate cos C. I'm going to start by getting rid of the 20 squared and the 10 squared because they're add-ons. So to get rid of those, I'm going to subtract 20 squared and 10 squared from both sides. My left side is now 24 squared minus 20 squared minus 10 squared. And I'm just going to rewrite what's left on the right side. These three things are glued to cos C, multiplication. So to get rid of those, I would divide both sides by minus 2 times 20 times 10. So 24 squared minus 20 squared minus 10 squared. I'm going to divide both sides by negative 2 times 20 times 10. And I would be left with cos C. Be careful with that last line. Students can have trouble with that. In one swoop, I am going to type that into my calculator. 24 squared minus 20 squared minus 10 squared is 76. And negative 2 times 20 times 10 is negative 400. I am going to get a negative decimal for the left side. Would that give me an acute answer or an obtuse? All right, let's find angle C. We are going to second function cos both sides, or take the inverse cos of both sides, and I will get my angle. Oh, I haven't approximated yet, sorry. There. Second function cos of negative decimal 19 gives us 100.95 degrees, or approximately 101 degrees. Let's look at the diagram for a second. Does it make sense that C would be 101 degrees? Yes, it does. The largest angle should be across the triangle from the largest side. And 24 is certainly the largest side, so the obtuse angle, if there is one, should be across from the largest side. Let's look at a word problem. Okay, the Great Pyramid at Giza in Egypt has a square base with sides of 234 meters long. The distance from the top of the pyramid to each corner of the base was originally, I thought that was cute, was originally 221.5 meters. We want to determine the angle each face makes with the base and the size of the apex angle. Although this pyramid is three-dimensional, we're not talking about a three-dimensional trig problem. We're just looking at one face. So we can use our two-dimensional trig thinking on it. So they were saying that the square base, so all four sides on the bottom, are 234 meters. And the distance from the top of the pyramid to each corner of the base was originally 221.5 meters. So we have our diagram. For A, we're asked to find the angle each face makes with the base. So we are looking for that angle there for part A. Then we're asked to determine the size of the apex angle of a face of the pyramid. An apex angle is at the top, as if you're standing on the top corner and looking downwards. So this angle along here, I'm going to call it beta. We're asked to find each one of those angles. So here we go. I have a triangle, not a right angle triangle, that has three sides and no angles. So I cannot use sine law. I have to use cos law. I'm going to find theta first. So to find theta, I need to start, there we are, my cos law with the side across from it. So for my cos law, I've got 221.5 squared equals, now I need my other two sides, order doesn't matter, 221.5 squared plus 234 squared minus 2 times 221.5 times 234 cos theta. I did this on purpose because the angle can be the hardest thing to find correctly. So I want to get cos theta isolated. I'm going to subtract each of these two add-ons to get a little closer to cos theta being alone. So my left side becomes 221.5 squared minus 221.5 squared minus 234 squared equals minus 2 times 221.5 times 234 cos theta. I have negative 2 times 221.5 times 234 in front of cos theta. So to get rid of those three things, I need to divide both sides by that. So my new left side becomes 221.5 squared minus 221.5 squared minus 234 squared divided by negative 2 times 221.5 times 234 equals cos theta. I really believe it's worth writing out like this before you touch your calculator so that you make sure you have the things in the right order. So let's type it in our calculator. So 221.5 squared minus 221.5 squared is 0. Take away 234 squared is negative 54756. The bottom, negative 2 times 221.5 times 234 is negative 103,662. I'm going to get a positive decimal. Will my answer be acute or obtuse? To find theta, let me do one thing at a time here, minus 54756 divided by negative 103,662 is positive decimal 5282 and so on. I'm going to leave that number in my calculator so that I don't lose to a lot of rounding. I'm going to solve for theta by taking the inverse cos of both sides. Second function cos of and so on. What I'm going to type in my calculator is second function cos answer button. My angle is approximately 58 degrees. So my corner is 58 degrees. The other angle that we're asked for is the apex angle, beta. And I don't have to do anything fancy with this. I know that my triangle is going to add up to 180 degrees, and I know that I have an isosceles triangle. So if I have 58 degrees in the one corner, I have 58 degrees in the other corner. So I can find my apex angle by subtracting from 180. 180 subtract the 258s is my apex angle. And it is 64 degrees. Some good cos law problems for you to try are on page 325 to 327. And that was for Alex because I need to put the range of pages. Would be 3 to 4, 3 and 4. And then if you pick 2 from 5 to 8 and 10, that'll give you some good word problems. And then for a challenge, pick 1 from numbers 12 to 14.